Hello everyone, welcome to Young Innovators. We know that transistor is a 3-terminal active component that performs the operation of switching and amplification. We also learned about a tilt sensor in our previous video. Let's take a transistor and a tilt sensor together in a circuit and check its working in today's video. Let's go to Tinkercad workspace and build the circuit. The circuit diagram is as shown. Components needed are a breadboard, a 9V battery, a tilt sensor, an NPN transistor, an LED, and a resistor. We take a 470 ohm resistor here. We have all the components needed and placed on the breadboard. Let's start the circuit connections now. First, let's connect the battery to the breadboard. From the terminal 1 of the tilt sensor, let's give it to the positive end of the battery, and the terminal 2 of the sensor will go to the base of the transistor. Collector of the transistor is given to the resistor, which is in turn given to the cathode of the LED. The anode of the LED is given to the positive end of the battery, and the emitter of the transistor is given back to the negative end of the battery. This completes the circuit. Let's click on Start Simulation and slide the tilt sensor slider from one end to the other to see the LED turn on and off. The current to the LED is given through the transistor here, and the tilt sensor is slightly acting as a switch. Moving further, we will look into another interesting component that has a wide range of application in most of the electronics experiment. A photoresistor. A photoresistor is a component that resists the current flowing through it based on the amount of light falling on it. You can see a photoresistor on your screen. Photoresistor is the combination of two words, that is, a photon, which means light particles, and a resistor, that resists the current flow. True to its name, a photoresistor is a device or a resistor dependent on the intensity of light that falls on it. For this reason, they are also known as light dependent resistors, or commonly called as LDRs. As the light falling on the conductive material increases, number of electrons that gains energy increases, which leads to a large number of electrons ready to move with an application of any external force like electric current. A photoresistor is a variable resistor whose resistance varies inversely with the intensity of light. Let's use this photoresistor in a circuit now and check the output. We will go to the Tinkercad workspace and build the circuit. Here is the circuit diagram. Components needed are a breadboard, a battery, 2 NPN transistors, 2 LEDs, 2 resistors, and a photodiode. Here we are taking a 10 kilo ohm and a 1 kilo ohm resistors. Connect the battery to the breadboard. We will short the two power leads of the breadboard. Connect the battery negative to the terminal 2 of LDR. The other terminal of LDR will go to 10 kilo ohm resistor. Other end of 10 kilo ohm resistor goes to the 1 kilo ohm resistor. The same end of the 1 kilo ohm resistor goes to the positive end of the battery. Other end of the 1 kilo ohm resistor goes to the emitter of the transistor 2. The base of the transistor 2 goes to the terminal 2 of the LDR. The collector terminal of transistor 2 goes to the base terminal of transistor 1. The two LEDs used in the circuit is connected in series with each other. The collector of transistor 2 goes to the base terminal of transistor 1. The two LEDs are connected in series and the cathode is given to the emitter of the transistor 1. The anode terminal is given to the positive end of the battery. The collector of transistor 1 goes to the negative end of the battery. Let's start simulation. The LED turns on. Light-dependent resistor is used to sense intensity of light. When intensity of light falls below minimum level, the transistor 1 turns on, which in turn turns on the transistor 2. A 9-volt battery is used to power the circuit here. You can increase the number of LEDs also. Transistor here is used as a switch. With these circuits, we understood the working of a transistor with different components. Hope all enjoyed the video. Thanks for watching.